This presentation is designed to outline the concepts, tools, and resources used by this organization for processing preventive actions and managing opportunities for improvement. Preventive, an action or series of actions that are designed to prevent, when put into practice, undesired outcomes. Action, something done, the process of doing something, typically to achieve an objective. Preventive action, an action or actions done to reduce risk or prevent undesired outcomes. Chernobyl. The Chernobyl reactor, located near the city of Pripyat, Russia. Population 12,500. Population of the surrounding area 150,000. It was commissioned in 1977. There are 4 reactors, 4,000 megawatt capacity, construction cost of approximately $200 to $250 million. 26 April 1986. The Chernobyl nuclear reactor meltdown. Causes: a variation and/or disregard for documented operating procedures, flawed design of reactor, and poorly trained operators. Immediate fatalities: 28. Long-term fatalities: up to 5,000. Total cost of the disaster: $235 to $250 billion. There are still 1,000 square miles around the city of Chernobyl, still considered unsafe to live, but almost 3,000 live in the excluded zone. The Piper Alpha. The Piper Alpha was a North Sea oil and gas production platform, operated by Occidental Petroleum. There were 250 workers. It began operation in 1976. Cost: $1 billion. July 6, 1988. Explosion of methanol gas. Cause: the overpressurization device removed from methanol processing system during repair. Pump was not locked out and started in an explosive atmosphere. 167 dead. Total cost of disaster: $12 billion. The Space Shuttle Challenger. The Challenger was put into service 4 April 1983. It flew 9 missions. It was considered the workhorse of NASA's shuttle fleet. From 1983 to 1985, it flew 3 missions a year. It had the first spacewalk during a space shuttle mission. It had the first civilian astronaut included in a NASA mission. The manufacture cost: $6.7 billion. 28 January 1986. 73 seconds into its 10th mission, the Challenger suffered a major malfunction and exploded shortly after liftoff. The cause: failed O-ring on one of the solid rocket boosters. 7 astronauts killed. Total cost of disaster: $17 billion. The Deepwater Horizon. The Deepwater Horizon was owned by Transocean. It drilled the deepest well in history at a true vertical depth of 35,050 feet. It had an operator crew of 146 people. Manufacture cost: $350 million. Cost of operation: $469,800 per day while under contract. April 2010. A well blowout caused a series of explosions. Cause: failed cement in the riser system. 11 killed. Estimated cost of disaster: $62 billion. What did all four events have in common? They could have been prevented. 4 events that changed life forever. $341 billion lost. 5,213 people dead. Families torn apart. One decision. One call. One opportunity. And none of these events happened. Why did they happen? There were several contributing factors for the meltdown of Chernobyl Reactor 4. Poorly trained personnel staffed the reactor, and the knowledge base was extremely limited for its proper operation. A system test was conducted while reactor data showed that the reactor was well outside test acceptance criteria and design parameters. The fuel rods melted at a temperature of 2,000 degrees Celsius, and without an effective containment structure, radioactive material and radiation were spewed into the atmosphere and spread via wind to the surrounding area and onward to the rest of Europe. The Piper Alpha. Piper Alpha maintenance personnel did not properly process the required permits designed to inform all rig personnel of maintenance activities. Removal of the Pump A overpressurization device, an insufficiently rated and installed blind flange, and no lockout provisions in place allowed the replacement ship to start Pump A in an explosive atmosphere. The Piper Alpha was also a pipeline hub being fed by 2 other platforms. The 3 platforms were connected in a ring pipeline, with the Piper Alpha serving as the primary hub. The damage to the Piper Alpha and the loss of life may not have been so great if the Tartan and Claymore platforms had performed an emergency production shutdown. Procedures did not call for any of the platforms to shut down in case of a fire on another. Occidental did not have adequate contingency plans in place for such a catastrophic event. There were no documented procedures in place for the Tartan or Claymore crews to follow that would have shut down the gas and oil feeds to the Piper Alpha, perhaps lessening the severity of the event. Both platforms kept producing and feeding the Piper Alpha. In reality, they were fueling the already horrific fire. Both the Tartan and Claymore platform superintendents cited pressure from Occidental management to keep production flowing. The Challenger. The O-ring in the right solid rocket booster of the Challenger failed at liftoff, leading to the separation of the field joint and structural failure of the external tank. The destruction of the shuttle was caused by aerodynamic forces with a resulting explosion of the unused fuel. The O-ring failed because it was not designed to operate in extremely cold temperatures, and the temperature preceding to and at time of launch was outside of acceptable design parameters. The Deepwater Horizon. Because of an inadequate cement job, seawater erupted from the marine riser, followed by a combination of drilling fluid and methane gas. The combination quickly transitioned into a fully gaseous state and ignited, causing a series of explosions. The riser cement job was rushed because of operator-imposed, cost-saving time constraints, and acceptance criteria was not met during riser testing. What would have kept all 4 of these events from happening? Preventive action. Preventive action, also known as opportunities for improvement, are any actions taken by the organization to eliminate the causes of potential nonconformities to prevent the possibility of occurrence. QMSP 6.4.3-001 Preventive action is the documented procedure maintained by the organization that makes provision for preventive action. The Preventive Action Management module, accessible through the Dell Corporation intranet site, is the organization's tool used to process opportunities for improvement. Preventive action starts with recognizing an opportunity for improvement of a product, process, or document, and documenting it in the Preventive Action module. The next step in the process is to design a preventive solution utilizing input from the Material Review Board and/or other relevant personnel. The next step is to develop an implementation plan. Again, input from the MRB and/or other relevant personnel is vital to a successful preventive opportunity. The next step is evaluating the plan's effectiveness. Did it add value to an existing process? Did it stop a potential nonconformance from occurring? There are 4 basic steps in capitalizing on an opportunity for improvement or preventive action. 1. Recognizing the opportunity for improvement. 2. Developing a proposed solution. 3. Implementing the proposed solution. And 4. Verifying the effectiveness of the solution. There is also a cost benefit. It's easy to look back and consider what should have been done. The real challenge is to recognize the opportunity before the problem occurs. The following is a real-world example of how a preventive action would have benefited an organization. An organization received an order for a stand-mounted chart recorder, destination Africa, with a cost value of $875, retail value of $1,950. The customer purchase order clearly stated the requirements, which included the following: pressure range, the number of pens, requirement to be stand-mounted, battery-powered, 90-minute charts, certificate of calibration, certificate of conformance, certificate of warranty, and a 24-hour turnaround for shipping. The customer received the chart recorder and used it to test a BOP stack. Test results were presented to the operator, and upon documentation review, determined that the chart recorder did not have a certificate of calibration. As such, the operator rejected the results of the test. The operator contacted and informed the supplier of the nonconformance and requested the calibration certificate be forwarded as soon as possible due to total operational shutdown. The supplier could not provide a calibration certificate because the chart recorder was not calibrated at time of purchase. Upon review of supplier purchasing documentation, the supplier did not request that the chart recorder be calibrated at time of purchase, not noted on the purchase order. The customer organization required, as part of the corrective action, that the chart recorder be sent back to the supplier, calibration verified, and be returned to the operator. Upon calibration of the chart recorder, it was found to have an as-found condition of out of tolerance, which made the results of the test invalid. The customer organization required the chart recorder to be adjusted, recalibrated, and returned. The customer also required an operator representative to be on hand to witness verification activities. The cost of the corrective action? $2,750 for round-trip plane tickets between Africa and Lafayette, Louisiana. $485 for meals and accommodations for the operator representative. $3,750, which is the operator's representative day rate. $225 for chart recorder adjustment and recalibration. And $16,000 for rig downtime. The total cost of the corrective action, $23,813. The total loss for the organization, $22,308. The organization should have made $875, but by not recognizing a preventive action opportunity, which would have been a review of customer requirements and purchase order review, it cost the organization $22,308. Moral of the story? It is much more cost-effective to prevent a nonconformance than it is to address a corrective action. Some things to consider. Does the organization have the resources to manage customer requirements? Are personnel adequately trained? Can current suppliers manage the organization's demand for product? And what is the organization's current on-time delivery rate? Those things can be addressed through preventive action. Preventive actions are generally not associated with corrective actions. Rather, they are associated with organizational change and managing risks related to change. So let's take a look at how preventive actions work. Let's say that this circle represents the manner in which the organization normally operates. Think of it as a pool of water. And someone, for the sake of this presentation, we'll call him Tim, feels that there is a need for change in the manner in which the organization does something, perhaps a change in a process, procedure, document, or product. In this case, the rocks represent the change opportunity. Now imagine that Tim throws the rocks into the pool of water. Change can disrupt how the organization normally operates, and the ripples caused by the disruption are essentially the consequences of change. If uncontrolled, the consequences of change can adversely affect departments within the organization, depending on the type of change. The ripples caused by a rock thrown in a pool of water are created by the energy of the rock hitting the water. Very much like change itself, it takes a great deal of energy and focus to manage change effectively and achieve the desired outcome. Without focus, the organization can waste a great deal of resources and possibly get undesired outcomes, again affecting some or perhaps all of the departments within the organization. But by recognizing opportunities for improvement, planning before implementation any change opportunity, and effectively using organizational resources, preventive action management can help the organization identify and achieve desired outcomes. Let's look at the top 5 ways preventive action benefits the organization. 1. It saves the organization money by effectively utilizing resources. The cost of preventing, which would be the lowest level possible, a nonconformity, is typically less than correcting or initiating corrective actions. 2. It reduces the risk that nonconforming product will be delivered to the customer. 3. Improves organizational processes. 4. Promotes ownership of organizational processes. And 5. Reduces overall operating costs by capitalizing on opportunities for improvement as well as minimizing the risks typically associated with change. So thank you for taking the time to watch this presentation and for your participation and support of the quality management system. If you have any questions, please send me an email at danny@deltank.com or stop by my office and we can have a conversation. Thank you.